Okay, so functions are also called modules. Okay, um, and depending on what language you're talking about, or most people in object-oriented programming, they call them functions modules. Remember we talked about that last time, that modules do something with the properties within objects. Okay? So this is where right now we're not really talking about object-oriented programming, but we start talking about modular programming, right? In order for us to use a function or a program, we need these different modules from other people's programs. So they're kind of like a miniature programs. But in C++, we need the program, we need the module main in order for other modules to run. Okay? So these are miniature programs that cannot run by themselves, but a main function can use them. So they allow complicated programs to be divided into manageable pieces. And that's what we started this whole semester with, that when we have this really complex problem, remember the snowman example, right? We identified that object, we identified the problem, and when we took that problem apart, and everybody's going to take them apart differently, right? Remember we talked about that we can have a program just for the eyeballs, right? And then we can have a program for the buttons. And then later on we talked about that, the buttons look like the eyeballs, right? All those going to be made out of coal. So why do I need to have two objects? Well, you're not restricted. So if you want to do two separate objects for those two different objects, right? Then you break it up into two separate objects. If you think they're similar enough, then you just create one program for those two. Okay? But mainly, we need to divide the program. And that's where you have the cable company. If you look at the number of lines of code, you might say that, that's kind of really hard to read. Right? There's too many lines of code. If we would break some of those pieces out, right, maybe I would read the code itself a lot easier. And that's our goal. Okay? So we've used predefined functions. We used functions from other people so far. Right? And what was the recipe? How did we use different functions from modules that other people wrote? What was the recipe? Yeah, we needed to include the library, right? And then after we had the library, now we had access to the modules, right? The modules, the functions within that library, okay? And then we had to learn how to use them, right? Because this is what we're going to call a parameter list, right? That parameter list is what we are sending to this watering can, okay? And then we have to figure out what is it returning? What is it that's come out of this function? Okay?
What's that bottom one?
Floor. When you have a floating point value, right? A list of floating point values, right? It can find the bottom, the lowest value, basically. Okay? Or basically ignoring the decimal point, the decimal values, right? So it's kind of like a rounding it down, forcing it to rounding it down, right? So C++, a function is similar to that of a function in algebra. It has a name and it does something. So we use some of these, and predefined functions are organized into libraries, and we use them by the include statement, right? So all this is not new, and we've been through the first 3-4 pages of the chapter. So the chapter might be long, but most of the concepts not going to be new because you've seen them before, you used them before. We just haven't defined them yet. Okay. Now we have two different kinds of functions, right? We either have a value returning function. Okay. Let's say we have the power of, right, the POW. Okay. We're sending the function the base and the power, right, the exponent. and then we're supposed to return the result, right? When the base is raised to the power. So you know that it's going to be a value return function, okay? But did we expect any kind of a return back from set W when we were manipulating the output string? We did not needed an acknowledgement that you sent it, right? Or you received my message. We were just assuming that, I set the width of the output statement, so it's going to be working that way, right? So it wasn't a value returning function. We did not have to worry about if something comes out of it, right? So in that case, like, you don't have a spout, right? It's just, in that case, it's just a bucket, right? You only put some things in. So we have a value returning and a void function that doesn't have anything coming out of it. So the void function, the only difference is, right, when we say that something comes out of it, we say, no, nothing's going to come out of it. And we just use the keyword, the predefined keyword void. And it means that we don't have to return anything when the function is done. Okay? So now we can ignore that return value. Okay? But if we do have a data type, then we require to return something because somebody is expecting us to return something from the function, and that's going to be the tricky one. Okay? That's going to be kind of tricky, and that's going to tell you why you need to test your code. Okay? Because if we have something like if x less than 0, okay, and you say that, let's say return x times 5, right? And then you end your function, okay? Long as x is less than 0, right? The if statement true is going to return x times 5. But what if it's false? If it's false, it has no return statement. So if you are testing your code with only x value less than 0, because that's a logical error, right? That's not a syntax error. What is the compiler going to assume at this point? There's going to be just a single-sided if statement, right? There's nothing wrong with it, okay? So in this case, if we have this if statement, x less than, or 0 is x then less than, must be a long day. X is less than 0, right? Okay. What you're doing here is you say return x times 5, right? But then you're not accounting for, let's say this is true and this is false. Okay, you're not accounting for if that value returns 0 or if it returns false, right? So while you are testing your code, the compiler not gonna say anything. So you say my code works perfectly fine because you're only testing it with x that is less than 0. There is no error message at all. But when you ship that code, right, or somebody tries it with x greater than 0, the function or this the code, the statement ends. And then, if this is in a function, the function tries to return something and says, well, you don't have a return statement. Now what do I do? Okay? So that's going to be a runtime error. Okay? So it can be trickier now that some of our code is somewhere else, not in main. Okay? Because we need to account for what comes back from that function. So value returning function. Include the appropriate header file in your program using the include statement. So just because in a function we still need to have modules, or we might need some modules from other people's libraries. So we need to have those libraries. So we need to know the name of the function, just like with variables. Okay, the function name needs to make sense, like main. Main makes sense that that is our main program, the main function. We need to know the number of parameters, okay? How many items your statements within your function needs in order to operate, right? And how many items you really need from outside, from somebody else, okay? We need to know the data type, okay? We need to specify that what is it that we're going to send that particular module or function. The data type of the value returned, and whatever the value or the data type of the return variable is, that's going to be the type of a function. So value returning functions can use the value returned by a value returning function by saving it to a further calculation, using it in some calculation, or we can actually printing it. Okay. So what do we do after the value comes back? What do we do with that value, right? You can use it in different calculations, or saving it in temporary variables for later use, or you can just print it out if that's what you need. A value returning function is used in an assignment or in an output statement. Well, a value returning function can be used because it's really nothing more when you have a output statement, cout. What is cout going to see? Not the function itself, but the data type that it's returned, right? So the function is going to be evaluated first, and then there is a data coming back from the function, and that's what it needs to print out. So it's really, even though it's a function, what you're going to define in a cout statement, it's still going to be just a simple data type, because that's what you return from your function. Okay? So there are some examples. So the only thing that we need to look at is, for our first part of the recipe, is the generic format of the function. Okay? So here it says function type. Okay? But really what that is just data type, right? Because the data type determines what a function type is going to be. So whatever comes out of the function, that data type determines the function type. Okay? So we have some kind of data type, space, right? Because that's a separate entity. And then we have the function name. And then we have a formal parameter list. Then we have the block to make sure that we are in that bucket, in that watering can, right? And then you have statements in there. The basic format is exactly the same as your main function. There is nothing new in this. Okay? Now the formal parameter list, it might be new to you because so far you think that main has nothing in it, right? So that's why I wanted to show you as an introduction to this chapter last week, you can have some values within the parentheses, okay? In the parameter list. So there's a formal parameter and there is something called an actual parameter. So so then you take it apart, right? And now it's not just about this chapter, but now the whole main function, the hello world example, gonna make more sense, right? So a function heading is all this. Function return type, which in this case is really just a function type. We have the function name, and then we have a formal parameter list, or a formal parameter in this type, because it's just the one single. What makes it formal? If you see within the parentheses, if you see the data type of the identifier, it is formal. If you only see the identifier name, and there is nothing in front of it identifying the data type, it's actual. Okay? So it can be, you can say int, or you can say number, and that number is a data type integer. That's going to be an actual parameter, or you can just say 5. Okay? Either one of those is going to be actual parameters. The formal parameter is going to have the data type. So if it's a quiz question or something, you just need to look for, is there a data type there? Okay, that's going to be formal. If there is no data type, even if it's an actual number or just a named memory location or a variable, it has to be actual. Okay. So here we have one single formal parameter. If we have multiple parameters, there's going to be a parameter list. The delimiter for the parameters is a comma. Okay, so they are so-called comma delimited parameters. And then we have the body, right? So we have the curly braces, and then we have the body of the function, or this is, now we kind of call it like the implementation. So we know what it's supposed to do, okay? So we implement the function, and then we handle the return type, okay? And that's basically half the chapter. If you understand that, then you're gonna be okay. So we need to understand the structure, right? And this was the structure. Is there anything confusing about the structure itself? Is there anything new in the structure?
The structure.
Same as main, right? You've seen it over and over and over again.
But so basically, what we're gonna do are separate programs that we're gonna integrate in one.
Right.
Okay.
So we need to understand the structure, right? What else do we need to understand? We need to understand that just because we have this program, right? This is, let's say this is a block, this is main, and then you're gonna have a function, okay? That's gonna be your func1, right? It's great that it's there, right? But you have to use that. If you don't use it, it's up to you. You're just taking up space. But in order for that to actually execute, you need to use it, okay? So that's what we call a function call. Okay, so we need to call that function, or this is just func1, right? With the actual parameter or parameter list. Okay. So we need to know the function structures. We need to know how to call them. Okay, and then handle the return type or the value. Okay, so that's all we need to know, and then that covers the whole chapter. Okay, so structure. The structure, we need to define them, and then we need to implement them, okay? So somehow we need to have something called like a skeleton, like a blueprint, okay? Or kind of like a wish list, what I wish this program or this portion of the program is supposed to do, okay? And that's what we're gonna call a prototype, okay? So the same thing when we were talking about identifiers, and we said we needed to declare an identifier, right? And after we declared it, we initialized it. Okay? Think about the prototype. Okay? So prototype, think about it like a define. Okay? Okay? So when we have a prototype, we are defining what that's supposed to do. But the prototype has no clue what it's supposed to do. Okay? It's just a wish list, a blueprint. The blueprint is not a building yet, right? Okay? So then, after we defined it, then we need to implement it. And after we implemented it, it actually functions. The syntax is correct, right? Then we can call it. But calling it, we need to know what kind of a parameter list we need in order to call that, or how to use that function. Okay? And then we need to know if we need to handle return. Okay? So, return expression. Okay. Anyway, I think that's going to be enough for PowerPoint stuff. Okay, so I want to show you different ways to think about these functions. if it ever comes up. So this is where we're moving into the area where you're going to have a main function or a main program, and it might have one single line of code. And your program can do all kinds of different things, but we only need one single line of code. What do you think? What's the line that we need? The actual call, right? If we can call a function from main, everything that you used to do in main, you can push it out to a function. Okay? So, why would you do that? Let's say you are printing out a receipt for customers. Isn't it your header for the receipt supposed to be always the same? Right? Why do I have to implement in the receipt when I'm printing out the receipt all the time the exact same thing? I can push this aside to another module, and I can just say print the header, print the details, print the footer, right? And the receipt is done. Okay? So in test 2, you guys had this exercise, right? So you had a header, okay? And then we have the item list, right? And then you had a total, okay? That is unique based on whoever the customer is, right? And then you thank the customer for shopping with you, right? Okay? So those things are static. They never change. Okay? The only thing that changes is the purchase right now. Okay? So this can be a function, right? And this can be a function. And then you can use that for your letterhead, for your receipts, right? For your inventory. You can use it in different areas. It doesn't have to be a receipt. Okay? It's just going to be a standard header for your company. Okay. So let's look at the basic rundown on our recipe on how do we thinking about implementing functions. Okay. So I want to raise a number to a particular power. Okay. What do? You go down to initial recipe, which I don't know how to raise a number to a power, then I need to use somebody else's module, right? So what is it we needed to do? Okay, so we're gonna use an include statement, and then we need to find out what library includes that, what we want to accomplish. Okay, so that was step number 1, right? Step number 1, because we want to use the POW out of that, right? Okay. So second step, what? We need to use it, right? The reason that I included the library is because I want to use it in my code, right? That is what we call the call, right? So you're calling somebody else's function, okay? So when I try to call it, what happens? What happens when it's called the IntelliSense, okay? IDEs are intelligent enough to sense the structure, and as they're sensing the structure, they know where to get the information to give you help how to use that, okay? That's part of the IntelliSense. What does it do? It gives me different ways of using this function, okay? Okay, let's say I want to raise 2 to the 4th. Okay, well, I'm raising a number to another number, okay? Do I see a data type right here for each one of, any one of these items? No, so is it formal or actual parameter? Actual parameter, right? I don't see a data type, it's actual. I see a comma in between, right? You see why you cannot use the comma when you're looking at integers, right? Comma has its own meaning, right? So that now we're gonna call this, everything in the parentheses, what? It's more than one, so it's the actual perimeter list, right? Okay, so that's a list now, okay? So how can we get a squiggly line then? There is some kind of an error. Do we know what the error is? We don't know, right? So how can we figure out what the error is? Okay? We needed to look at the error message, right? We don't get nervous just because we don't understand why we get the squiggly line. Logically, you say that if I have a 2, I can raise that to a power of 4, right? But this one says you can't. Okay? So this one says, what is the error message said? More than one instance of an overloaded function, POW matches the argument list. Like, whatever that means, right? So at this point, we don't know what an overloaded function is. Okay? Remember last time we talked about when I showed you the structure that we can use the plus sign to add 2 rooms together, to add 2 buildings together, right? Something that you not normally think about when you're using the plus sign. Okay? The plus sign is actually an implemented function. And when you implemented the different meanings, okay, it becomes overloaded. I'm using it for something that wasn't intended originally. So there are multiple instances of overloaded functions. Okay? Anyway, so I don't know what that means. Okay? So I'm trying to learn about it right here because I don't want to Google it. Okay? So now what do? Is I go through the list. What are those overloaded functions? Okay? How can I call? Now this is the first instance, right? This is 1 out of 6. What is going to be returned from this POW? A double, right? This is the return type, right? And then what is going to be the perimeter list? It's expecting a double, comma, double, right? Okay. What about the second one? What's going to come out of that function? It returns a double. What is it expecting? It's expecting a double, and it's expecting, comma, an integer, right? So you can go through this whole list. So this one going to return a float, not a double now, right? So it's going to be a smaller number, okay? It's expecting a float, comma, float. Okay? And then you have a float coming out of the function, expecting a float, comma, integer. And this is the fifth one. There's going to be a long double in, and long double in. 2 long doubles, right? And then we have a long double coming out of the function, and we have a long double, comma, integer goes into the function. But we don't really know what a base is or what the exponent is, do we? How do we use this function? Okay, so it's not very descriptive, but at least we can have a clue that do we have, let's say, an integer, comma, integer. We don't have that, right? So we need to adjust this to something that fits the requirement for that function. Okay. So so which one do we use? Which one you want to use? Let's do a float integer, right? Okay. So can I just say 2.0? Does that turn it into a float? And now the second number is implemented as, or interpreted as an integer, right? There is a little danger when you're looking at sending actual perimeters as numbers, right? Because you might not understand what data type they are. So if we would have saved that in a data type, let's say float equals and then integer equals, then the actual perimeter list would make more sense that, oh, this is a float, this is an integer, okay? But isn't that annoying that we cannot raise 2 to the power of 4? Okay? I don't care what these people are implementing. I want to raise 2 to 4. Now what do? You don't wait for somebody else to give that to you. You're going to say, you know what? I'm going to have a function performing those operations for me, right? So this is my goal, to erase 2 to the 4. So what do I need to do? Okay, so let's say, let's just put this one in. So this was step 2. Use the function with something that is required, right? So something that is implemented, right? Something that has already been written for me. And if I use that, it will perform the operation I want to perform. Okay? Now, but every single one of these implementations also returns something, right? Okay? So what's the third step we need to do? What can we do with the results? So we basically, step number 3, handle the results, right? Okay. Float, let's say t. Right. So we can print the results, just like the book says, right? We can print the result out right away, right? We can save it for later use. Or, let's just reuse this one. What else can we do? No, divide by 15. So in this case, what am I using it for? Whatever is returned from the function, right? I'm using it in other calculations. Right? So there's going to be, the function going to be evaluated, a float value comes out of it. So it's really, I'm dividing a float divided by an integer. Right? So, and I'm assigning that value. So I can do all those kind of things with the function. Okay? So, step number 3 was to, just to handle the return value. Okay? Now we know how to use somebody else's function. Okay? If we don't have this particular idea, you're doing this on Notepad, you might have had to go to internet or to the documentation to figure out where we made a mistake in using this function. Because a Notepad does not have this IntelliSense to show you how to use somebody else's function. Okay? So now back to our learning about functions. And let's see if we can create our own function. Okay? So let's go through the recipe. What is the recipe? What is the recipe for using variables? We need to know the data type of the variable, right? We need to know the name of the variable, right? And then we had to initialize it, and then we had to maybe use it, right? Why would you have a variable if you're not using it, right? Okay, so we needed to use it. That's the same step for functions. Okay? So in order to use a function, we need to make sure that we tell the program we have our own function. Our own function doesn't come from IOStream, doesn't come from map. It's coming from my own implementation. Okay? So how do we create functions? What's the recipe or the baseline, the blueprint for functions? Okay, function type, which is really a data type. Okay. I need a function name, whatever that function is called. Okay. And then I need to have some kind of parameter list. The parameter list is the parentheses. Okay. So data type, and then let's just call it identifier 1. Right. And then a data type data type identifier 2 dot dot dot, right? Okay, so that's my base. Okay. So what do I need? I need to raise 2 to the number 4. And what is it that we're expecting out of that? Let's just make it really complicated, right? So let's expect an integer back, right? So what is the data type that's coming back from the function? It's integer, right? Maybe I'm gonna call it my POW, right? So maybe I want to relate it to POW somehow. So it has to have a name, right? So we're still using the camelback to name this particular expression, in this case, function. And then we have a parameter list, okay? Now we need to use the semicolon after it. So what is it we're trying to send? What is it we're trying to send to that bucket? What do we need to have? 2 integers, right? Our goal is, so you need to know what you're trying to accomplish, right? What we are trying to accomplish is 2 raised to the power of 4, right? So 2 is an integer, and so what do we call 2 then? 2 is a base, right? And then we're raising it to a power or exponent, right? Okay? So as you're thinking about that, you know how you're going to call those variables, right? So let's say we're just doing it simply. Int x, int y, right? Because that's what you would do in most cases, right? So that was our step. Let's call it A, so we can distinguish it from, let's say, step 1, 2, 3 is calling somebody else's function, and now we are creating our own recipe. Let's just call it like step letters, so we can distinguish it. So step A is now at this point, do you think the program or a compiler knows what this function is supposed to do? The compiler has no clue what this function is supposed to do, right? But I think this is the interesting thing about functions. Look what happens if I say my POW parentheses. It already sees that, oh, you have some kind of a string followed by the open parentheses. You're probably trying to use a function. Let me see if I can find somebody has that function with that name or not. Okay? That's when you're going to see that C++ is case sensitive, because you can see if I'm using the lowercase p, it's like, oh, nobody has that function. I don't know what you mean by that, right? So now I can use POW parentheses and say, you know what? You do have a function that I can reach, I can access. And what is that function requires? Requires 2 integers, right? Do I have a clue what x is or y is? I don't have a clue, right? But what is going to come out of it? An integer, right? Okay? You're reading it just like you read somebody else's code or somebody else's module, right? But the nice thing is you can make it even more user-friendly. What if we would say, this is my base, and this is, let's say, my exponent, okay? So now if I use my POW, it actually tells me that I'm expecting an integer that's base and an integer that's an exponent. Isn't that nicer or user-friendlier? Now, that's not going to make a difference for the user that's going to use your program, right? Okay? It is just for you to figure out what you're trying to do. Because you don't have to use it this way, right? You can say exponent here and base here. You know, maybe if you're dyslexic or something, you might read everything like that, right? You might implement it that way. Just because I'm implementing my function in one way, it doesn't mean you're going to read it that way. And that's why I need documentation. It's okay, I have this function. I'm not giving you the source code because that's my job, right? That's how I make money. selling the modules, okay? But I need to give you enough information so you can use it. If you don't know how to use it, you're not going to buy it, right? Okay? So that's when you have to be user-friendly from a programmer's point of view. If it's too complicated to use or too annoying to use, you're not going to use your modules in programs. Okay? So at this point, okay, now it says, you know what, I'm expecting the exponent before I'm expecting the base. But just because we have the prototype, it's kind of like in a variables, we haven't initialized it yet. We still have no clue what to do with that. We can already see that the program sees it. We have a good sense how to use it, but it's not implemented yet at all. Okay? So I can't use it yet. So what is it we have? What is our recipe? We have a prototype, so that means we had to define it, right? We needed to define it by the base structure, whatever C++ requires us. So what is missing now? We need to implement it. We need to give it some kind of a body, okay? So what can we do? We can give it a body, and what is it that we are expecting? We are expecting something back. Okay? So that means then why do I have this blue squiggly line? Okay? The prototype is an actual command that is being implemented, right? Now in this case, I'm not just using it as a prototype. Whoops. Okay. Yeah, I was meant that squiggly line there, right? Okay. That squiggly line was because of that, because we used this line as one individual line of code, not as part of a structure. So if we take that one off, now we have a function, and that function actually returns a value. Okay? And this is something that you should do as you're writing code. Okay? Put in some fake value, put in whatever value you can that matches the data type that you need to return. And make sure that the function can be called, and it's going to return something, and you can handle the return value. Later on, you can implement the body of that. Okay? How that function actually is supposed to work. Okay? So what other option do we have? We do not have to implement it right here with the function prototype. When we're declaring the function, we can go after the main function, and we can implement it outside main as an independent program. Okay? Now the body is over here, and we still get the squiggly line that says, well, something is not right. What's wrong? The structure, right? If this is, we're trying to implement, but trying to implement what? We don't have a function, right? So what you do is, you take your prototype, not including your semicolon, okay? And you use it just like you used to use main. So the prototype is there to let the program know before you get into main, right? Because when you compile, what do? You see the structure, if the structure, your program is correct within main. So that means before I get into main, I need to know what functions to expect. That's why we use the include as a beginning of our programs. So by the time you get to the main function, it knows how to resolve, how to interpret those functions. Yeah?
Because you only have one line of code right there on the end.
Right?
Do you even need the brackets?
Yes. Because it's still going to be a body of a function, just like with main. Okay, so we need to have a bucket to hold the water. Think about it that way, right? It's not like when we have if and the while loops, right? That you didn't really have that bucket concept. And next time when we meet, we will talk about the scope of a variable That's going to be very important, how far we see outside that bucket. Okay? So yeah, that's a good question, that you do need to have the brackets even if it's a single line. So now we have a function prototype, okay? And then we have step B, okay? So that's going to be the implementation of the function. What happened? Did I? Yeah, don't you just love that? Love technology. Okay. So we have a step B. So the second step, first create the prototype. Step B, create the body. Okay. So now what do we need to do in order to create a body? Okay. Now this is gonna be also important. Just because you have something in the prototype, you do not have to match that when you're implementing it. Okay? So the integer, the data type, does not create a memory location for that type of data type. Remember when we said we needed to create a memory location, name memory location that wasn't pointing anywhere until we initialized it? Okay? So here is where you're gonna create those data types. So what you name it in the prototype doesn't have to necessarily match. So why is that nice? I can write a program, I can understand what a prototype is, and you can implement the code itself and call the variables totally different. I don't have to give you the name of the variables I want to use, right? They're independent. So here I can say x and y. So with x and y, I want to use POW, and we say x and y. Okay? Well, wasn't that the original problem? That was our original problem, that we had to, we could not use just two integers.
Yeah.
So what can we do then? Because I'm still stuck on the idea we're going to raise that 2 to the power of 4.
You just change this instead of an x to float x or double x.
Well, can we just change it? Or how do we change it temporarily?
Cast.
Yeah, we can cast it, right? Okay. So, let's do a cast to float, right? Isn't that what we want to accomplish? And now POW doesn't quack at me. But as far as using POW from now on, right, I can just type in my POW and send it 2 integers. And I don't have to remember to cast it all the time. Let my program, I figure it out once, and from now on I'm using my function. Okay? So I'm not stuck with somebody else's implementation. I can implement my own. And that's where the beauty of user-defined functions are. You adjust it to your needs. Okay? Now what's the problem right now? We're not going to return anything, anything meaningful, right? Okay? So, so what can we do? We can say int, right? Darn it, we can say int. Okay? Isn't that what I need to return back? Okay, so how do we return int then? We can cast what comes out of it, right? Okay? So, so now this is where you're kind of thinking about that whole concept of nesting things. Okay? Because what comes out of this original code comes out, a float comes out of it, right? So what I do is static cast. What do I need to cast it into? An integer, right? And what do I send this function? What do I send this static casting? Everything that comes out of the POW, right? But really, that's just a float. Okay? So I need to put that in parentheses. Okay? And that is the end of my line. Okay? You guys see what happens here? Right? You take it apart, and then you see this is the static cast. Originally, we had two integers. Integers are coming in. POW doesn't allow me to handle integer. So I'm forcing one of the variables to be a float. Now POW works just fine, returns a data type, and that data type I want to force into an integer, right? And I really do not want to save it into a variable, but soon as there is a integer comes out of this function, I want to return that out, right? We can have that in many different lines, okay? But we really don't need. We don't need to temporarily save it, okay? If you want to, there's nothing wrong with that, okay? You save it. But this would be probably the most efficient way to do that, all of that in one line. Sending functions variables, something comes out of it, you send that to another function, something comes out of it, you send that back to the calling function. Yeah.
I was wondering, what if you wanted to use, instead of like an integer, what if you wanted to use like, or instead of an integer that was up in the normal IOStream library, what if you wanted to use like a different library, like a string or something like that? Could you do the same thing? Like, would it work exactly the same?
With any function, as long as you understand how the function works, what the function expects, and what comes out of it, right? You just have to adjust to whatever the function requires,
Okay.
right? So right now, let's say you guys wrote the code for pi. Do you want to go through that again? No. Do you think it would be nice to save that code and call it mypi? And then you have to use to calculate the area of a circle. You would say, I don't have to type in 3.14. I can do that a lot more accurately now using my own function, right? Okay. So you need to understand what you're trying to accomplish, the different ways that's possible, and then whatever means necessary, you just make it happen, right? I mean, we can call it mypi and just return 3.14, right? That's going to be perfectly fine, right? Okay, so now, when I have, let's say, an integer t, integer t, I can say my POW 2, 4, okay, and no more squiggly line, right? Do you see the value of that? And even if we're gonna say, let's say, void function, okay? So there's void, okay? And with that void, I'm gonna say my project, okay? And let's say I'm not gonna send anything to that project, okay? Empty perimeter list. That's my prototype, right? That's step number 8. That's my prototype. I'm gonna go down and go under the implementation of my project, and I try to implement this function. Okay? Is anything needs to be returned out of that? No. Okay. I'm saying that whatever I have in main, I think all that is just too complicated. Okay? All this stuff is just too complicated. I want to put all that into my project. Okay? And so we have a prototype. We have a prototype for my project. What does that mean? main knows there is a project prototype, right? Okay. So I can even I can show what that main is, understand what a project is, right? And I can just do this. What do you think that's going to do? The main project, I'm going to say, find the code, whatever code is in that my project. Execute all that. Don't return anything back. Come back to the main project, okay, and exit the project, right? So now when you're looking at main was really this complicated stuff. You pushed it away. Okay? You can have each one of your assignments in different functions, and then you can just say, well, I need to turn in project number 1. You call project number 1. The other functions can be there, but you're not calling them, so you're not using them, right? So, does that concept make sense? Okay, so we really need to understand this basic concept in order to move any further. Okay, now this is not in the book, but just so you guys understand the basic idea why we were using the libraries. Okay. Remember I showed you the header file? So let's say if I create a header file for my project. What is a library? A library is a collection of header files, right? So I'm going to add a new item. It's getting hot again. Okay, I'm just going to call it testing. Okay, so now I have a header file. Okay. We don't need any of this stuff. Okay, now I don't want this to be in my main project, in my main source file. Okay, I can put that in a header file. Okay, I can even put the prototype, if I want to, into that header file. Okay. Now this header file says, okay, I don't know what you mean by POW. Okay. So what am I missing? I'm missing the library that has that function defined, right? So I can still say include CMAT, right? The squiggly line goes away. I go back to my program, and my program says, I don't know what you mean by POW. Why not? What am I missing? We go back to the original recipe. What do we need to do when we use somebody else's project?
Include it.
We need to include that, right? We need to know where do we read it from? Where is it implemented? So if I do include, now I don't use the greater than and the less than signs. That's for built-in libraries, right? I'm trying to use my own library, okay? And you can see that as soon as I put in the quotation mark, it says, hey, you have a testing.h. Do you want to use that? You see that IntelliSense again? It sees that H file because it is in my project, okay? And says, okay, yeah, sure, I want to use that H file, okay? Now I'm interpreting the code in that H file, header file. And now the squiggly line goes away. Right? There's my POW. Isn't that the same thing what we had? Well, it still sees it, but anyway, so if we would not have the library and it doesn't understand the function, right, we will get the squiggly line. Same thing when we're using somebody else's function, okay? So hopefully that helps you understand really that at this point kind of everything kind of starts flowing together. It's like, oh, that's why we did this, that's why we did that, right? That's why I had to use include, yeah.
But if we were, like, say we were supposed to make a program like this, and if we just sent you the CPP, how would you see the header file?
Well, that's not in the code, it's not in this class, but you would have to send me the H file too,
Alright.
right?
And so
And that's
pretty
why-
much the header files are just like global variables, right?
Now, you remember what a header file is when you compile it? The header file gets expanded into your code. It's like in your code, but it's stored separately, right? So, I don't know, it's kind of like, I'm not really sure how to use C++, I need to Google it. It's the same thing, right? It's like, I can call Google, but the data is not here, it's coming from somewhere else. So the same thing here. I'm calling this header file, I'm using a function from that header file, but it's not really in my source code like we do in this class. Okay? So as far as assignments is concerned, don't worry about the H file. My whole point with this H file is to try to make you understand what the libraries are doing. Okay? And now you can see why we need to learn how to use a function. Just because we have a function, we might use it wrong. Okay? Whatever the implementation is. And if you don't agree with the implementation, now you can implement your own. So this is where, all the complaint stops that, well, Microsoft messed this up. You think they messed it up? Write a better code then. Okay? So that's when you see it's not that easy. Okay? But that's what this the whole chapter is about. This whole recipe, right? So now we have a structure. We need to know what a basic structure of a function is. Okay? In order to use that function, first of all, we need to define it. When we define it, we really call that a prototype. Okay? The order matters in the parameter list, right? Why is the order matter? I mean, you guys saw that in the implementation, right? That's another reason why the implementation can be somewhere else. The prototype cannot be stuck using the same identifier name because I don't know who implements it, right? I can be the one that says, this is the project, and this project needs to handle GPS data. I'm going to give you GPS data. I need you to a location coordinates back in a different format, right? I don't know how you're going to do it. That's your job, okay? My job maybe is the interface design. I need to be thinking about the colors and where buttons are and those kind of things. While I'm doing that, you're implementing what I need to do. But I can't wait for you to finish your job. So because I can't wait for you to finish your job, I'm implementing your code, but I'm not going to implement it properly. I'm implementing it with a false value just so I can continue on with my job. I'm not going to wait for a real value. Okay? But eventually when you're done with your job, you're just going to cut and paste it in here, and then my program also going to work. That's where programmers needed to really, you don't ever really write a code from beginning to end. You're going to get the perimeter list. This is the values you get. This is what I'm expecting out of it. You figure it out. Okay? You're not going to get any values. I want you to figure out whatever means necessary. And when it comes out, I need you to hand me pi. Right? But I know pi is coming back, so I can use my program and just hard code pi until you figure out how to calculate pi. Right? Okay? So that's when you're thinking about different implementations and you're really relying on somebody's flowchart, somebody's pseudocode, a teamwork, everybody doing their job. If they don't do their job, I can still fake it and still continue with my job until you finish, right? This is when you understand that if I implemented this in this exercise, I can take the header file, and when you start a new job, you just say, you know what, include my previous header file. So at this point, if my POW is really complicated, a year from now, I don't even remember how I implemented it. I only had to work hard on it once. And after that, I just know how to use it. Right? So that's what you try to do with computers, that you need to implement things. identify what I'm using over and over again, break that into the function, and then just use it. Okay? So you don't ever have to struggle implementing it again. Okay? So, so step number 1 was define it, prototype. Implement it, which is the body. Where can we implement it? We can implement it before main as part of the prototype, right? Then we don't need the semicolon. Okay? Long as we have the prototype, we can implement it anywhere in the code after main, right? We can implement it in a separate file, and okay, so that's the implementation. So after we have the implementation, now we can use different programs to call our program. Okay. So if I would have int help, okay, that's my prototype. Here is int help. I try to define it. Now this is a value return function, right? Okay. Okay. And now this function, that new function I have, because this function is defined after I defined the my POW, now this function can also see that and I can call it. So now, as long as we have this function, we can use it in other functions. So one function can call another function, call another function, call another function. Okay? But in order to understand the basics, right? Define prototype. Implement is the body. Okay? Call it. Call it anywhere you need to call it. And then if it's a return value function, handle that return value. How do we handle it? Print it out, save it in a temporary location, or use it in other calculations, right? Okay? And what we talked about today, there's basically nothing new that we haven't talked about yet, because you guys were using this, it's just you didn't define all the different terminology for them, right? Because you were using somebody else's. Now you're writing your own. Okay? So whatever assignment so far made sense, go back to that, right? And do the same thing I did over here. Copy the whole main, okay? The return you need to leave there, right? Copy the whole body and copy it into another function. And in the main, you should only have the function name with the parameter list. Okay? And that's all you need in main now. Everything else can be implemented. Okay? You still cannot hand in an assignment saying one of you implements the function and the rest of you just gonna call it. Okay? So it's still gonna be plagiarism that way. Okay? You still have to implement your own. Okay? But now you can actually create a solution, save it as a function, and then distribute it, and everybody else just calls that function. But everybody gonna make the same mistake if the implementation is wrong, right? But that's the beauty of it. And then eventually you say, well, functions are not right. Let's make it objects, and that's where object-oriented programming comes in. When you don't know how the waves are waving on the sea or something, somebody can create that module, right? And that's what Pixar does a lot, right? That's where the programmers go to the ocean, and then they watch the waves moving, and then as they watch the waves moving, they come up with an algorithm, and then they implement it based on that, right? Is that what the water really doing, right? How does the shadows fall into the water? What does that do underneath the water, right? The reflection versus refraction, right? They do all those kind of things. Eventually, they come up with this module. So next time they write their next animation, they just use the module from the previous animation. They don't ever have to figure out how to create a water surface. Okay. So that's where the money is, right? Somebody that can come up with that. Okay. Anyway, so that should be okay. So I recorded it. So if it worked, I don't know if I have signed on this thing, but if it worked, then I'll post it on eCampus, so you guys can go through this exactly what we did today. But when we go upstairs, I know the assignment is due today, but I still want you guys to write at least one function today. Okay, so you guys can see how that works. Okay, so see you guys upstairs.